Okay, so we have a special event lined up for you all this morning. And yes, it is another update about the Vera C. Rubin Observatory, because who can get enough of the Vera C. Rubin Observatory? But today we have a special treat for you. We have Phil Marshall, who is actually up at the summit in the dome. So Phil, welcome to the stage.
All right, thanks very much, Dan. Can you hear me okay? All right, morning, everybody. Let me get out of the way. I'll stand back so that you can see what I'm blocking here. Here you go. I want to introduce you to the Simoni Survey Telescope here at the Rubin Observatory in Chile. We're at the summit facility, standing in the dome. It's lunchtime here in Chile. So most people are at lunch over in the casino. It's not a gambling venue. It's the word for the lunch place up here. There are some people here working. I'll give you a view of them in a minute, but I wanted to start with this view because it's, well, I think somewhat breathtaking. I'm actually out of breath because I just hot-footed back from lunch and up the stairs with Luis, our safety assistant. But even so, I think you can agree it's quite something. So this is a somewhat rare view of the Simoni Survey Telescope. I'm standing on the floor of level 8 of the observatory building. And usually observing the sky, of course, the telescope point up, or at least at some acute angle. Here, the telescope is parked horizontally, and that's because there's, well, for two reasons, actually. One is there's work being done on the dome, which I'll explain in a minute. But also the camera, the commissioning camera, ComCam, is off at the moment, and so the telescope is out of balance, and so it can safely only sit in this position. So you're getting a rare look down, almost down the barrel of the telescope. So talking of barrels, you see this hole here. This is the future home of LSST-CAM. This is where the camera will slot in. And literally from here, we'll get pushed in through the back. It'll actually poke through the secondary mirror. The M2 mirror goes on first, and then the camera gets pushed through. And the back end of the camera will only stick out a little bit out through this hole. So in a minute, I'm going to take you round the gantry a little bit and show you the side view. But I wanted you to have some time admiring the telescope from here. I'm not sure if you can quite see it. Let's look. If you look down here, let's see with my finger. There's a lot of black here. This is a netting that's covering up where the primary mirror will go, M1, M3, the primary and tertiary mirror. This black netting sits in front of it and keeps the dust off it when we're not using it. If you can see here, there's a little hole. If you can see that this grayness, that's a view through to where M1, M3 will be. What's in there right now is the M1, M3 mirror cell, but with the surrogate mirror. So it's not a shiny silvered glass mirror. It's a piece of not very shiny steel, but it has the same weight as the actual mirror, and so helps balance the telescope. That's its purpose. Okay, I'm going to pause for questions as we go round. I think we've got, I want to say, half an hour for all of this. I've got a couple more views to show you. That's Alison Rose recording everything for posterity. Some of you have met her before. But in case there's questions, I'm happy to start answering, and then I can take you to show you a little bit more. Might be easiest for Dan to repeat them. I don't know.
Yeah, if anyone has any questions, raise your hand. Yes.
So where's the primary, secondary mirror? When do you put it in?
When will it go in? It'll go in actually fairly soon. The ComCam is due to go back onto the telescope shortly. The glass, I think, will go on over the next 6 months. There's a sequence of things that have to be done, and the idea is to have the glass on with the commissioning camera on, do some tests, and then take the camera out, M2 off, and the camera out, and then install the camera, the LSST camera, once it's arrived. So there's a bit more testing to do with ComCam first before LSST cam goes on next spring or summer.
So Phil, this is Pat. It's a little hard to get the sense of scale there. So how far are you standing away from the telescope?
Good. Okay, let me see how close I can get. I'm about here. I'm about 10 feet in front of the 10 feet in front of the big circle. The circular structure, I believe, is about 8 meters in diameter, about the same as the mirror. So that the whole structure is very compact, that you'll see in a minute. And I think this structure is similar size to the mirror. It might be easier to see when I start walking around. You'll probably get a slightly better sense of scale. Did that come through okay? I heard my earbuds popping a bit.
Yep, loud and clear, Phil.
Very good. Okay. All right, shall I move on?
Yes, please.
All right, I'm going to pick you up. It's gonna the picture will go a bit funny while we're walking, and we'll just do the best I can. I'll try and hold you steady when we've stopped. Okay, so we're going to walk around over here a little bit, and I'm holding you down so that I can look at the floor, make sure I don't step on anything. But if you look up, you can see the roof of the dome, and that yellow structure there, that's the bridge crane that we'll use to lift the camera up and into the telescope. And you might be able to see there's people up there today working on it, mending it. The whole dome is enormous. It's the biggest observatory I've ever been in. It's a 600-ton structure that moves not with the telescope, so it's slower than the telescope, but it moves at night to kind of keep up with the surveying. When you're in the dome and it's moving, it's quite something. Let's head over here, past a little crane, down over here. Right, here's a sort of side-on view. You can see the M2, the spider, where M2 and the camera are suspended. And if you look up there, that's the gantry where the camera will be worked on while it's mounted on the telescope. So that actually extends out into the telescope. When the telescope is parked horizontally, Kevin or someone like him, Margot, Travis, etc., they'll be walking out along that gantry to tinker with the camera. And especially exchanging the shutter is the big thing we'll do up there. Okay, let's tuck ourselves in over here. And then I can give you the side-on view. Let's see if I can do this. Okay, so that's this silver structure here. That's the side-on view of the M2 mirror cell. That's where the secondary mirror will go. And then if I rotate a bit, you can see, well, not very much inside the telescope. Okay, I'm going to move now, and I'm going to take you to another view. So the picture's going to go wonky, but round we go. We'll go and see another side view. Here we are back in front of the telescope. And what I didn't show you, if I go slowly around, then this behind me is where the door will be. Outside here, there's a lift that lifts equipment up from the 3rd floor, which is where the clean room is, the white room. That lift brings things up on the outside of the observatory building, and then we open the door, bring things in, and then lift them up with the bridge crane. All right, off we go again. These are light baffles. We have to have airflow through the dome, but if air can get in, that means light could get in. So every set of louvres on the outside has to have a baffle in front of it. Okay, and let's see. Apologies for the seasickness. Okay, there's a better side view. There's another gantry on the far side for access to the camera, and there you can see the structure that holds the camera and M2. And then if I sidestep this way a bit, see how far I can go. There you can more or less see the back of the telescope there. So, you know, for years we've been making jokes about how stubby this telescope is. It really is. So when you're here, it's almost like looking at a soccer ball. It's like a little spherical, well, big spherical telescope that's going to roll around the sky like this. And it's amazing how short and compact it is. Right, let's wheel you in, and I'll stand here and see if there's more questions from the floor.
So, Phil, what's the distance between the M1 and the M2 mirror cells?
Well, excuse me. It's probably around 8 to 10 meters. I don't know exactly. There's probably someone in the auditorium who knows that number better than I do. In fact, that may be true for a number of these questions coming up.
Okay, so it's about the same as the diameter.
Yeah, yeah. That's why I say it's almost like looking at a rolling soccer ball.
Great. Any other questions for Phil while he's here? Once in a lifetime opportunity to ask questions to the dome. Yes, Phil, Pat would like to know what you're doing up there today, besides the tour, of course.
This is probably the only time I'll come up into the dome today. Yesterday, I was up getting a tour from Victor Cravendam, project manager. He gave a few of us a tour. There's a couple of people from the NSF here, as well as Bob Blum and I. And so we were getting the update on how things are going here. We got to inspect the underneath the telescope, which is where the new cold system for the camera will go, and the cryo system for the camera already is. So it's kind of nice to see slack equipment installed underneath the telescope. We also saw the capacitor banks under there. They're fun. This is a battery-powered telescope. It has to accelerate so fast to change position on the sky, and then settle within 2 seconds in order to be able to take another crisp image. The accelerations are enormous, and so to power the telescope in one of those 2-second moves takes something like the equivalent of 1 million Type C batteries, what's down there in the capacitor banks. But the good news is that we don't have to go and replace. We don't have to charge them up fully every time. We don't have to go and buy more Type C batteries. 90% of the charge gets replaced on the deceleration. So it's kind of like in your hybrid car, the deceleration gives you a free charge, and we get 90% of the energy back again, which is good. So we did that yesterday. That was the tour. Today I'm not going to be back up here. The rest of the day will be talking to people downstairs in the control room and the office area down on level 3. And then later on tonight we'll do some observing with the observing specialists. They're here with some of the calibration group, putting some new calibration hardware on the auxiliary telescope. They'll do some observing with that, and then in the second half of the night, they'll do some more of their miniature imaging survey, which is one of the things we're doing with the auxiliary telescope at the moment. That uses the LSST scheduler software. So this was true last September when I visited as well. We're already surveying the sky at LSST speed, just with the auxiliary telescope, not with the Simoni survey telescope. But it's nice to see, the script running and the observing specialists doing their thing, which is mostly keeping up with how the data is looking and tracking problems, working on problems, troubleshooting, making tickets, that kind of thing. So while the scripts run in the background. So it's kind of you should think of it as a semi-automated battery-powered telescope.
Phil, how many people are working there at the summit?
Let's see. It's probably, I would say, a couple of dozen today. It's a little bit quieter than usual because of the crane work in the dome. So the only people in the dome right now are, I think there's 3 technicians from the vendor. There's Luis, who came up with me, and then there's Alison Rose here, who's making a documentary about the building of Rubin. Downstairs in the control room, there's people from the safety team having meetings. There's the engineers and technicians doing what day work they can, planning, preparing for when they can get back in the dome and continue work on installing the light baffles and beginning the process of putting ComCam back on.
What are people thinking is the most challenging thing in the next month or so that needs to be done at the observatory?
The most challenging thing in the next few months. In general, I would say, in very general terms, I think the most challenging thing now is not losing any schedule. So they're really counting the days here now. There was a lot of activity yesterday on the telephone trying to get the bridge crane people here today rather than next week, because they really didn't want to lose 7 days. It was bad enough losing 2 days, you know. So that in high level terms, that's the most challenging thing is staying on target. Technically, I think the installation of the camera will be a very big deal when it arrives. There'll be the actual installation. The movement of the camera up onto the telescope is the straightforward bit. It's the connecting it and the plugging it in and everything, all the many cables and pipes and so on that need to go into connecting it is going to be challenging. Logistically, there's a lot of work to do on the dome still, putting up the light baffles, and they're big things that take a lot of effort to put up. And so far, it's been a challenge to get them up at the speed we need them to go. So, and that needs to happen while other things are happening in the dome.
We have a question from Alex at the back.
This kind of follows actually what Risa just asked, but what all do you still have to do before the camera arrives in these next couple of weeks, months?
Okay, so so at the summit facility, before the camera can go on, this round of installation and testing involving the mirrors and ComCam. I think the mirrors actually will come a little bit later before LSST, after LSST camera arrives. The getting ComCam back on the telescope and doing more tests of the system, even though we can't observe the ComCam yet, having the telescope balanced with ComCam on it allows all sorts of in-dome testing of the telescope, and that I think is the main program before LSST cam arrives. The glass, I think then most likely is the glass will be ComCam will get taken off again, the glass will get put back on, and then ComCam on once more in order to go on Sky first. That's the most likely thing that will happen, but we'll see. There's still a lot of sort of flexibility with the scheduling of things, and the team here will be playing it week by week as to which plan they follow. So it's the observatory is in a very dynamic state right now.
So it sounds like you do some imaging with ComCam without the glass in place. I was wondering what exactly ComCam does, what sort of data you get from ComCam, or is it essentially a mass proxy for the LSST cam?
We won't do any imaging of with ComCam until there's glass on the telescope. But it's some would say primary function is to be a proxy on the telescope, as you said. And it's not just to balance the telescope with the map. It's a refrigeration pathfinder. So we can test all the refrigeration systems with ComCam on, rehearse the installation that I just described, all of that using the commissioning camera before LSST cam goes in.
Okay, so does that mean that ComCam not only has sort of same mass distributions, but it also essentially has the same thermal mass as LSST cam and so forth, so you can simulate all of these cooling systems and everything?
Yeah, in fact, I saw ComCam yesterday. It's on the same cart, bright yellow cart that the LSST cam will sit on, and in fact, it was plugged into the structure, the integration structure that will be attached to this teal structure behind me. So ComCam is we think of it as a small camera, but it's in a big black structure that looks a lot like the barrel of LSST cam, same size, same weight, and that's so that it can be mounted in the same integration structure and then placed on the telescope in the same way. So it has a number of functions, ComCam, as a proxy in a number of different ways.
Well, interesting. Okay, any more questions for Phil? We've got about another 4 minutes, so make the most of it.
I'm going to head back over here while you think, and we can. Oh, there's a crane in the way.
Yeah, so
Okay.
I had a question. Once
Go.
start running and are going smoothly, how many people are going to be in the dome every night? Are you going to let it do its own thing and not have to have someone babysit it? Will there always be a crew there in case something goes wrong? Are you going to rely on neighboring domes to worry about that?
So in steady state survey operations, there will be 2 people in the observatory building every night. That's the minimum. In practice, there'll be there'll probably be a few more than that at the beginning of the night, but in the dark of the night, it'll be the 2 observing specialists on their own. And they'll be in the control room downstairs on level 2. No one is allowed in the dome at night while it's moving. And that's because the telescope moves so fast that it's dangerous to be anywhere in the dome when it's moving. Someone was telling me yesterday that if you were to take this telescope and move it at full speed, operating speed, in its horizontal pointing, swing it round the dome room, the nose of the telescope that you see right here would be moving at 15 kilometers per hour, which I know from treadmill experience is a little bit faster than I can run. So only 2 people at night, and they're down in the control room. In the daytime, there'll be more people up here doing kind of ongoing maintenance, preparing for the night's run. But at night, it'll just be the 2 observing specialists.
And I guess on a kind of related note to that, what's the balance of staff sort of operating a normal observing run and the balance of duties between the dome, between the center down at base camp, and then between here at SLAC and at NORLab?
Okay, so on a typical day at Rubin, during the survey, I guess there would be maybe 20 people up here on the summit during the day. Down at the base, there'll be, I would say, another few tens, and it will vary in time as people come down to visit and so on. And then at SLAC at the US data facility, I think there'll be another, Richard's going to balk at this, but I'm gonna say a few tens associated with the US data facility and the data processing in very general terms. And then in the Kavli building, maybe 10 to 20 people, a mix of operations staff, visitors, and so on, that will be actively working on the data, preparing for the next data release and so on. So it's that kind of order. Rubin Observatory in total has will have around 200 people working on it, a staff of 200. Some of them will be part-time, many of them will be full-time, depending on their role. But that's the ballpark size of the staff at Rubin.
Great, thanks. Hey, any last questions for Phil, or Phil, if you've got any last things you want to say?
Trying to think of any final words.
When is the
Well, I guess
camera going installed?
When is the mirror going to be installed?
The camera.
Oh, the camera. So when it gets here, sometime roughly speaking in the northern winter-ish timeframe, it'll take a little while to test it, make sure everything's okay after the shipment, and then there may be some waiting for the testing that's going on the telescope to continue, and then there'll be time needed to take ComCam off, put LSST cam on, and that involves moving M2, of course. Yeah. So the first photon through to the LSST camera, my guess is it would be sometime around next northern fall is probably what we're looking at. And you should hunt down Aaron at Coffee for a more precise view, but roughly speaking, that's what we're talking about. And then we're expecting the survey to start in, as I said on the slides the other day, sometime around fall of 2025.
Thanks.
All right, so I'll leave you with this view. There's the future home of LSST Cam, which I hope some of you managed to see this week. And it's pretty special being here to see where it's going to finally come to rest. And I'm very glad to have been able to show it to all of you as well.
Thank you so much, Phil. It's been amazing to see you up at the summit. So let's give Phil a big hand.